Hey everyone, thought I'd make a quick video talking about a current situation going on in the Northeast, and that is this nor'easter that's sitting well to the south of the New England coastline. And I wanted to focus on this storm because this week in this chapter we're focused on clouds and precipitation. Now, during the lecture videos and all the lecture material, we're talking about how do clouds form and how does precipitation form. But in this video, what I want to concentrate on is applying that in your forecasting skills. And when we look at things like how much precipitation is going to fall, for right now, since it's the fall semester, we're really just talking about rainfall. But as you can see out west, they have another storm system out there. And since these locations are a little bit higher in elevation, they've gotten really socked with almost 2 feet of snow in some places. We have a really cold air mass coming down from Canada, meeting up with some moisture coming in from the south. So, during these in between seasons, really just spring and fall, we tend to get some big swings in weather. But for right now, I really want to just concentrate on the Boston area just because it's a little bit more relevant to myself. So, right now, I'm on Pivotal Weather and I selected the GFS, and I want to actually zoom in a little bit. So, I'm going to go into regional, click on the United States, and then click the Northeast tab. And so what I can see here is I can see how this storm system is behaving according to what the GFS thinks. Now here, this is the 12Z run. So this is the GFS run from 8 o'clock this morning. And so as I move this through time, I can see what is going on with this storm. And because we have a high pressure system that's way to the north, it's really sitting in southern Canada, it's suppressing this low pressure system from moving on up and out to sea. So for the past couple of days, we've really just experienced this very raw, windy, dreary type of weather here in the Boston area. So as you can see here, according to the GFS, this area of low pressure is really just rotating on itself. And you can see here that we have these spirals of waves of precipitation at times that come in and out, affecting the Boston area. So it's really just going to remain dreary for the next day or two. And then as we get towards the weekend, you can see that this low pressure system, it's way off screen here, but you can see based on these isobars, this area of low pressure finally exits the region sometime on Saturday night. See, valid Sunday at 0Z, which is 8 o'clock at night on Saturday. So then after that, we have high pressure that moves in, and then we have a little bit of a wave that may affect us on Monday. But when we look at precipitation, how much precipitation is left to fall, which in my line of work, when you deal with clients who have outdoor projects, oftentimes rain will affect those projects, whether it's paving roads or doing yard work or something along the lines of that. Rain does impact projects, and therefore it costs time and therefore money. So if a client asks me, what am I looking for or how much more rain is going to fall in my area, a great resource to use on Pivotal Weather would be either the 3-hour accumulated QPF, which stands for quantitative precipitation, or what I like to use is the total. So since I posed the question on how much rain do we have left, I would like to use the total. So when you click on the total here, you can actually move your mouse over and you can see how much precipitation is left to fall from this system. So according to the GFS, not much in terms of precipitation is going to be left to fall in the Boston area. You can see how it's kind of a sharp cutoff. It basically, the most abundant precipitation goes from the southeastern corner of Connecticut, Rhode Island, and into southern Massachusetts or southeastern Massachusetts. And especially the hardest impact region would be Cape Cod and the islands. So based on this, how much more precipitation we have to go, and when we go to Sunday at 0 Zulu, here you can see, and we know that from the previous slide, that this storm was pretty much exiting the region. So if we were on the Cape, we would say maybe another, 1.5 to 2.5 inches of rainfall in between there. And then for the Boston area, really just light intermittent showers according to the GFS. Now, what I want you to do is, remember, I want you to compare models. So let's go to the NAM And I like to use the 3 kilometer NAM. It's a little bit better just because it focuses a little bit more on resolution. So the idea is that it hopefully gets a little bit more forecasts correct. And we can do the same thing. We can do here we go, surface and precipitation. There we go. Not time for snow yet. So here we can move this along through time. And remember that the NAM doesn't go out as far. So we can go all the way to the end of the forecast period, which would be about 60 hours out, okay? And so here you can see how this differs. So this is showing, about an inch left to fall in the Boston area. So here, this is a little bit more. So now we're talking between now, which it's Thursday, the 10th of October at around noontime, till about Saturday night at 8 p.m. The high resolution NAM is calling for about an inch to, an inch and a half, maybe even up to 2 inches near the Boston area. The further you go out west, it's a little bit lighter. And then here on the Cape, it's showing to, produce a lot of rain between now and then. 3 to 5 inches of rainfall is pretty substantial over the next couple of days. So how do you know which model is right? So this is what I want you to kind of focus on as you create your forecast going down the road, is which model tends to be more correct. So remember that we can still use MOS. And so here in the Q category, we can use MOS, and MOS is great because it just gives you another point of view into how much precipitation is going to fall between now and then. So when you create your forecast, you're creating your forecast for a 24-hour period. So let's say that you were going to create your forecast for Boston for tomorrow, Friday, and then Saturday. So that would be a 2-day period. Well, one thing you could do is you could look at the GFS MOS, which is this at the top, and we can see how much precipitation has fallen in a 12-hour period. And you can see here that there's a 1 here, and then there's nothing else after that. So basically between now and essentially Friday night into Saturday, the GFS is only showing, the GFS MOS that is only showing a category 1, which a category 1 basically relates to between 0.01 to just under 1/10 of an inch of liquid equivalent, or how much liquid has fallen out of the sky. And that basically meshes well with what the operational GFS was talking about. Now remember that the NAM was a little bit more robust. Actually, it was quite more robust. So when we look at the NAM MOS, let's see what they're saying. So the NAM MOS, right, when we look at Q12, here it's showing a category 2 between now and Friday night, and then an additional category 1 between Friday night and Saturday morning. So in total, we're talking about a category 3, and so that's anywhere from 0.25 to 0.49 inches, so anywhere between 1/4 and 1/2 an inch of liquid precipitation. So how do I mesh these models together? Well, I do know that the GFS was on the lower end. The 3-kilometer NAM was much on the higher end, but when you look at the average in MOS, the GFS MOS was very close to the operational on the lower end, and then the NAM MOS was pretty much right in the middle, so a category 3. So you can use this information to kind of gauge what or how much rain is going to fall in a certain time frame. So this is a great tool that you can use when you mesh these models together. And not only that, remember we're looking at the 3-kilometer NAM. So what we can do is we can look at the operational NAM and we can see what its point of view is as well. And so see here, when we go all the way out to about Saturday, let's go through all the day on Saturday here, we can see that, the Boston area is pretty much on that cusp between, about 1/2 an inch or an inch. So when we're talking about how much rain is going to fall between now and then, in my opinion, I would say anywhere between 1/2 an inch to an inch based off of what these models are saying. So you kind of get a consensus, and the idea is to blend these models together so you can gauge a better forecast. So let's say how much rain is going to fall between Friday at midnight and let's say, right before we hit midnight on Saturday. So that 24-hour period. So here's my timestamp. So 6Z, that's about 1 a.m., so close enough. So here, because this was initiated at 12 Zulu, which would be Thursday, if you want to use the total accumulated precipitation, what I would do here is I would imagine all this to be 0, okay, because it's adding the total from Thursday, which is today, but I want to know how much rain has fallen on Friday alone. So what I can do here is I pay attention to my timestamp and I just move this forward and I go all the way into Saturday at 6Z. So here you can see that, Boston's ranging from about, 3/4 of an inch to an inch of precipitation. So what I would do is I would just take, let's make it easy and let's just say, an inch of precipitation. So if I subtract 0.4, which is what it was previously, from Thursday's accumulated precipitation, if I just subtract 0.4 from that, it basically gives me just a little bit over a half an inch of precip. So when we look at the category, it basically comes to a category 4. So when you look at that drop-down list on the Google Forms, when you submit your forecast, you can submit a 0.4, or I'm sorry, you can submit a category 4 in here to correlate between about a half an inch to an inch of liquid precipitation. And basically that's not a bad guess. This is a really hard system to forecast for, just because these bands of precipitation, they're not well modeled really. This is kind of a difficult situation. So really, operationally speaking, if a client asks, I would say that yes, the potential is there for an additional half an inch to maybe even up to an inch. Or if you want to get a little bit more high tech, I would say anywhere between a half an inch and 3/4 of an inch of precipitation at most, between, that would occur on Friday in that 24-hour period. So this is one way that you can use MOS, you can use Pivotal Weather, and you can kind of mesh these together to figure out what or how much rain is going to fall in a certain period. And remember that you also have the grids. So you can use what the grids are and you can use what the National Weather Service is thinking. So let's say, I wanted a 24-hour period beginning, Friday at 12 a.m. So you could just take out your calculator and you can just add up, 0.4 plus 0.9 plus 0.18 plus 10 plus 0.08 plus another, tenth of an inch. So, right here, this is, about half an inch, maybe a little bit over a half an inch of rainfall. So here, this is where you can use all the tools that you've used or learned so far to create a better forecast. And this is what meteorologists do. They just take a bunch of data, and granted, I haven't shown you a whole lot yet, and we're getting to that, but this is how you start to mesh together these different models and use these different tools. And I want you to be able to be comfortable with this because you're going to have to do it on your final project. And so this is the stuff that I want to see, is you using different tools to get a consensus, to basically form a bias to help make your forecasts better. So I hope that video helps. I hope everybody's having a great week thus far, and I'm looking forward to reading your discussions and looking through your forecasts.